Right. I come to the wireless networking space from a slightly different perspective. I've worked in development assistance for a number of years, mostly looking at the issue of telecommunications in Africa and how to improve infrastructure there. And there are huge challenges there. And in the mid-90s, when it seemed like the commercial internet was exploding and there was all this opportunity, and it seemed that that Africa was being left even further and further behind. We funded a lot of research into what might break down the barriers to access in Africa, and it came down to the fact that it was expensive and there just wasn't the resources and the will to deploy infrastructure. Then mobile technology took off, and suddenly there was mobile infrastructure in Africa, and it exceeded everyone's wildest expectations, but there was still no internet. And I remember the epiphany I had when I met Thomas Cragg in 2003. He was grinning madly and holding a little mesh tube in his hand. And it struck me then that there was something that needed to be done here, because this technology was so affordable and could be deployed, but wasn't somehow being taken up. So in the institution I was at before, sorry, I just got off the plane from Cape Town, so I'm a little whacked out. If I become incoherent at any point, just be patient with me, okay? So I funded a lot of groups to actually train people to hack wireless devices and build antennas and build their own infrastructure. But it didn't really take off. Culturally it was very good, but it didn't really take off. And for a couple of reasons. One, it's still complicated. It's still tricky. And Open Mesh have done a huge amount to mitigate that, and it made mesh networks virtually plug and play. But there was something else missing in Africa, and that was voice. There's no point in delivering data infrastructure if people can't make affordable phone calls. So when I joined the Shuttleworth Foundation in 2008, a couple of years ago, the first thing I did was to find some of the smartest people I knew in the wireless hacking community, including Electra and some others from around the world, to actually look at the problem and what could we do. And we realized that we didn't have the technology we wanted. What we wanted was a kind of open mesh device that was weatherized so that you could put it outside, but the one that had an analog.
Is this the solution, your outdoor enclosure?
Yeah, it's beautiful, isn't it? Yeah. But that had an analog telephony adapter built in, because the other alternative, you could plug a SIP phone into an open mesh device, but it's still expensive. And the key for us, we realized, was bringing down the cost of that CPE device. You couldn't really scale the network unless you had a cheap CPE device. Luckily, we had a guy named David Rowe, some of you may know, who's an Australian hardware hacker and has designed open telephony devices in the last few years. And he looked at the two devices and said, I could design that, I could build that. And that was so far my paradigm at the moment that we would actually conceivably, as a tiny foundation, sort of develop our own hardware, that I completely dismissed it. But over the course of the workshop, I began to think, well, maybe we could. And happily, it's a foundation that encourages us to take risks. So that's what we did. We built a new device, and it does actually look like that, minus the packing tape. And we call it the mesh potato. It was mesh and pots and the ATA and thank you. Alberto Escudero Pascal was there. He's a Spaniard. Patata, mesh potato. Anyway, the mesh potato is what we came up with. And the last 18 months has been a process of going from prototype to another prototype, and finally we're going into full production next month with a device that looks very much like that. We're basically stealing Ubiquity's housing design, which seems very, very clever. They haven't patented anything. And it's really a low-cost server gateway calls, or you can actually then, if you have a services license, get DIDs and actually, become a proper telephone company. And that's the idea, is that everyone can form their own telephone company and not wait for, in Africa, MTN, Vodafone, Safaricom to come and deliver your network to you, but build it and be able to, let other operators bid to connect you. That's it in a nutshell. I'll bring a bunch of mashed potatoes in tomorrow if you want to check them out. This is the latest design.
Questions? Yes.
Actually, sick
Yes. Well,
So it's actually like, say, Linksys device. So actually, it's a Linksys device with an integrated AV.
Yeah, with an ATA. A little bit different in that it's been designed for Africa, so the ports are, thanks to Electra's work actually, the ports are a lot tougher than your average access point, so designed so that anything short of the direct lightning strike should survive. What's that?
If I have problems with the copper being stolen and sold.
Yeah, it is actually a huge problem. No one will, certainly in South Africa, no one will deploy copper infrastructure for that very reason. And in fact, Telcom, the incumbent, spends a fortune on copper security. It's keeping the copper line secure.
It's been nice to see.
Steve will bring us some more of
Is
this tomorrow.
Mozilla working on this project with you guys?
Mozilla are filming it.
Okay.
So as part of their open web project, Drumbeat, yeah, they're filming it. And the director of the Mozilla Foundation, Mark Swinman, used to be a fellow at the Shuttleworth Foundation.
He's my PhD.
Okay, small
He was
world.
telling me about it, I was wondering if you'd be here.
So what will be the cost of this device for the African people?
A good question. So right now they will retail for $119, wholesale for $89. And that's based on our initial production run, $500, 500 units. And as soon as we can get up to something like 5,000 units, we expect that price to come down to $20 to $25. Sorry, that will come down to a price of $20 to $25, but will drop. And so we hope to get the wholesale price down sort of into the sort of $60 to $70 range.
And you're open to other people augmenting your production, right?
Oh yeah. So and to other people manufacturing it. In fact, we kind of hope that Ubiquity will take a look at the schematics and start making their own. Because ultimately, my fellowship ends next March, and this is what I'm going to be doing. My next career is the village telco, but we really don't want to be in the hardware business. Other people are probably better.
Okay, I was going to say, have you read the open hardware project? The open hardware.
This is
trademark hardware. Oh, it is the open
yeah.
hardware.
No, so this is completely open hardware. With the schematics, everything's available.
Okay, so
The only thing that's not publicly available is the building materials, and that's because we're partnering with a Chinese manufacturer and they source the bits for it. But it's pretty easy to reverse engineer what the building materials are. So.
Any other questions?